So I would quickly go through the parts of scripting section that we dropped due to time constraints. So I will go down to this section here called More Scripting. And previously in this chapter, we looked at making your first short script, the motivational example, and we're going to continue with that, making it a little bit more elaborate later. So scripts, as mentioned, is used to perform complex repetitive tasks without user intervention. And all Linux commands can be used in a script, including wildcards. And just to repeat, if it's just a one-line command you want to do again and again, then alias is probably more suited for this. And that's covered under hints and tricks. So going back to the example script, my first.sh, and I have made this script. I'm just going to cut it here to show how it looks. And let's do that. And you can see this is the content. And there is also a second file named file2dat that we want to process. And I will show you where it is. It's here. So we looked at file.dat, and this is file2dat. And we could, of course, open an editor and change the content of my first.sh and just rerun it. Or we could create an improved script copy of the script. So let us copy my first script, this one, and make a new one. And here I'll call it count abcd.sh. And now there is such a script here. And let us open that in Nano, like this. It looks this way. And we're going to change grep from file.dat to grep in this $1, which is a variable, which is the input variable. So now we can change our script so that instead of each time we are looking at a new file, we will actually just be able to run the same script but with an input. And so we are going to go here and we are going to change file.dat. And then we are going to put in $1. So this will now take the input $1. So we'll do that, save it. Yes. And let's check that it actually has executable permissions. It should have inherited, but let's see. It does have executable for me, which is what is needed. So I'm now going to run my script, count abcd, and now I can run it on, like I did before, on file.dat, but instead of having it inside of the file, it's now taking an input. And let us see what we got in this output. That we still got 2 as we expected. So let's now try and run it again. And instead of running it on file.dat, we are running it on file2.dat. So we are running count abcd on file2.dat. And now let's see what we got in the output file. We got 3 because that's what we had. We had 3 lines in this script instead. So now we have changed our script. So from being able to run on just the one file that we are changing repeatedly inside of the script to being able to take an input so that we can just use the same script all the time and run it on the input we give to it. That is already an improvement. So this is making it more user-friendly. And that is what we did here. So let's try and continue upgrading our script. And now I'm going to copy it. So I'll make yet another copy of this script here. And I'm going to rename it or make a new copy with the name count string plus sh. And then I'm going to edit it with nano like this. And as you can see, this is the script. And now I want to edit it so I can search for different strings than just ABCD. And I'm going to do that by giving it yet another input here. So 2. And now we are giving it one input, which is the file, and one input, which is the string to search. So let's save it. That. And then I'm going to run it. And I'm going to say that I want to run it on this file that. And I want to search for ABCD. See what we got. Got the same output as expected. So let's try and search for this string within file 2. And we now got 3. What then if we are searching for a different? Let's search for the string line. So I am running again my script, and I'm giving it in an input variable for file that, and then I'm telling it what it is I want to search for. And here it is a line. And it runs, and the output is 1 because, let's see, just to remind ourselves what is in file that. In file that, it looks this way. Let's again also look at file 2 that and see that there are several instances of line. So let us run it on file 2 that and look for line and see what our output is. It is 3 because there are 3 instances of line in this. So here, and here. Where's this one on the map? So now we have a script which takes 2 inputs, one which is a file and one which is the string we are searching for. Of course, this script can be changed many times so that you can also get the output directly to screen or get it to another file or to do different things, of course, to different number of variables. But this is already showing some of the strength of scripts in Linux. So commenting, that was covered. Let's see. And let's try. Yeah, this is, you could make comments to this script we made here. Count strings. So if you were going to be nice to yourself, you would put in comments, because that means that when you look at the script in a year, you can figure out what it's doing without having to go through it and look. And it also can, you can tell yourself what is the input that you expect from it. So usage and things like this, you can also make it so it outputs the usage with a print statement, for instance. But this is actually a good idea. So we are telling it what it is we're doing in each of the lines. So counting the number of lines with word count, wrapping for a specific string, and so on and so forth. I will also briefly cover the more advanced example. Let's go back to this. There is an example script, image find. So it's here. Should be here, yes. And that is used to find all files with the extension .png in a specific directory. In this case, this directory here, and then copy them to a directory named my images. Then it searches for file with ER as part of the name and redirects the output to a file named some image files.txt. So as you can see here, I have a slightly different path. So I would change this here, image find, and I would go in and add intro Linux so it works in my path here. And here you first have the shebang telling it that it's using bash to use bash. Then it's going into this directory here, and it's looking for types file with names matching .png and anything else. And on that, it executes copy and to this my images, the things that are files with the name ER in, and then it sends those to some image files.txt file. I'm going to save it. And then this let's see if we actually have the my image directory. I do. Let's see if there's anything in my images. It's not, it's good. Let's see if there's anything in image. There is, good. So let us try and run image find. And then now let's see what's in my images. Now it copied everything as it should. Here, all the things that matched, so all the .png files. And then there should now also be a file, some image files.txt. Let's see what's in that. There we have those of the files that has ER in their names are listed there. So it worked as we hoped it would. There is also one more example here, which is more useful. It's actually doing something that you might want to do. And in this example script, we find all files with the extension .eps in the current directory and below, and then copy them to fit directory figures. Afterwards, it creates a variable fig files containing the full path to the directory with the figures and all the files in it, and then it loops over all files. We're not going to cover loops. You can go to the intermediate bash in December and learn more about loops. But anyway, inside the loop, we will convert all the .eps files to .pdf files. And the extra line that is here before, it is just a way to avoid that the newly created .pdf file end up with the extension .eps.pdf, which is what I got first when I tested this. But yeah, you can see here you are doing find in this directory and below it for types for type file with names matching EPS, then copy them to home figures. And for anything in this fig files, that is a variable we create, we do this thing here, converting PS to PDF. And you might want to do that in order to use it for your, maybe your intent or something. Okay, that was that.